In this video, the topic we'll be covering is airfoils, and more specifically, how lift works. Now before we start our presentation, let me define some objectives we'll be covering. First, we are going to define the forces relevant to flight, such as thrust, drag, and lift. Second, we're going to analyze three different kinds of lift, using the Bernoulli equation, the Coanda effect, and using deflection. Third, we're going to examine the lift-to-drag ratio. Fourth, we're going to evaluate different airfoil shapes and properties. Now, what is lift? The definition of lift is stated as the perpendicular component of the surface force created as a fluid flows past the surface of a body.
The lift equation is comprised of four main terms. You have rho, the density of the air, v, the velocity of the plane relative to the air, c, the coefficient of lift, which is an experimentally determined number that is dependent on the shape and size among other factors. You also have a, the cross-sectional area as viewed from the top as seen in this picture.
Now, how does lift work? In order for an aircraft to rise in the air, a force must be created that is greater than the force of gravity. This force is called lift, and it's created when air flows over an airfoil. The air on top of an airfoil flows at a higher velocity than the air flowing underneath. Simultaneously, this results in a lower pressure on the top than on the bottom. The higher pressure below pushes the airfoil upwards, creating lift.
When lift is greater than the weight of the aircraft, then the plane will begin to rise. It follows that when the weight of the aircraft is greater than the lift, the plane will begin a descent. Drag is defined as a mechanical force produced by the interaction and contact of a solid body with a fluid. Thrust is the force produced by the engine of an aircraft. When thrust is greater than drag, the plane will accelerate, and when drag is greater than thrust, the plane will slow down.
There are three main types of lift that we will talk about in this presentation. First, we will learn about Bernoulli lift. Then we will talk about the Coanda effect, and after that we will take a look at deflection lift. We all know the Bernoulli equation from class. The equation states that if there is a pressure change, there must also be a change in velocity. Lift is produced when the pressure difference creates a force that is greater than the weight of the airfoil or aircraft. The Coanda effect describes the phenomena that occurs when a moving fluid sticks to the surface it is close to due to the viscosity of the fluid. As you will see in a couple slides, most wing shapes have a trailing edge pointing downwards. This is because of the Coanda effect. The air flows along the top of the wing, and then when it reaches the end of the wing, it continues to flow in the direction that the end of the wing is pointed. This causes the wing to move upward as a reaction force during flight. Deflection lift, which is also called Newtonian lift, is probably the easiest type of lift to visualize because most of us have experienced this. Think of paper on a windy day. The paper flies away because a force from the wind is being applied to the paper. It is the same principle for an airfoil. The air is providing a force to the wing, pushing it up. This is also how planes make bank turns. Drag is defined as the parallel component of the surface force as fluid moves across the surface of an airfoil. The drag equation looks eerily similar to the lift equation. It has some of the same terms in rho and v, and c, the coefficient of drag, is a term that can be determined experimentally. But another difference is the a term. A is no longer the top-down cross-sectional area. It is now the frontal cross-sectional area, like in this picture. The lift-to-drag ratio is an important measurement for an airfoil. In general, the more lift you produce, the more drag you produce, but they usually increase at different rates. There are many things that can affect lift. The two we are going to talk about today are camber and the angle of attack. Camber describes the asymmetry and curvature of an airfoil. As you can see, there are many different shapes of wings. A wing that is symmetrical on both the top and the bottom, closest to the airline wing on this slide, is said to have no camber. The reason that camber is used is because wings with different amounts of camber have different properties, such as different coefficients of lift and drag. This changes the total amount of lift or drag a single airfoil can create.
The difference between where the wing is pointed and the direction of the air flowing over the wing is defined as the angle of attack. Increasing the angle of attack results in an increase in lift and drag. This graph shows a typical relation between the angle of attack, lift, and drag. Increasing the angle of attack results in a parabolic increase in drag, and for lift you can see a relatively linear increase up to a certain point. The critical angle of attack is the angle of attack which produces the maximum lift coefficient. Going above this angle will result in the aircraft stalling or experiencing a sudden decrease in lift.